The importance of these events were very high for the whole society. And of course, scientists were also reporting that water quality has gone down tremendously, and at places starting from, so very near to Delhi, there is a place called Garhmukteshwar. So starting from there itself, the water quality of river Ganges is not suitable for bath. Okay. And all of you understand the importance of river Ganges in the Indian society, right? So initially government took certain short-term measures. So one religious event actually is organized every year in Allahabad, Magh Mela, in the month of December or January, where thousands of people, or say lakhs of people, they gather and they stay for almost a month. So there is a big religious event. People come and go, but then thousands of saints and seers, they remain there for 1 month, and every day they take bath, they take dip in the. Now because of this pressure, as I mentioned that certain short-term measures were taken, and one of the measures was all the industries, those who were discharging their effluent, which was directly or indirectly getting into the river Ganges, they were closed. So Central Pollution Control Board through State Pollution Control Board gave the direction to these industries to stop their activities for certain period. So for example, if this Mela is organized in December, so post monsoon, so monsoon, it's a kind of cleaning activity for all rivers. So starting from October, they used to give a direction to all industries to stop their activities. So that by the time this fair is organized, October or November, so by the time this fair is, or this Mela is organized, the river water quality improves. But then this is just a short-term measure, you cannot. So then Central Pollution Control Board did a comprehensive study. So first study they took was to understand the problem. What are the causes of, or which are the factors responsible for this kind of quality, this kind of water quality. So one thing was obvious that there are two sectors. One is municipal sector, that is our sewer, and then industrial sector. So these are two major sectors. So within industry, it was easier at that time to take a stock of industry, because that effluent is private actually. I mean, if some private industry is discharging effluent, you can say that this is the private effluent. This ownership goes to that particular industry. But as far as sewage is concerned, it is a public ownership. The municipal corporation, they need investment. So they started with industry. And then they did very comprehensive inventory analysis in Ganga basin. And they found three major polluters within this basin. One was pulp and paper, another was distillery, and third one was tannery. Right? Very good report. Very good report. They did comprehensive analysis of till level 2 streams. Means, so for example, Ganga is the major river, the major stem. Then there are tributaries. So for example, Yamuna is tributary to Ganga, or Gomti is tributary to Ganga, or Ramganga is tributary to. But then there are sub-tributaries. So for example, Yamuna. So there is a river Hindan, which is which is tributary to Yamuna. So it becomes level 1 tributary to Ganga. And then small drains. So they could find out that which tributary is responsible. So for example, for river Ganga, they identified before Allahabad, before Yamuna confluence with Ganga, they identified two rivers, Ramganga and Kali, the major culprits. Major culprit means they are carrying the most of the industrial effluent in this basin. Then they went further, which sub-tributaries are contributing to Ramganga or Kali and so on. So as I mentioned, they identified three sectors: pulp and paper, distillery and tannery. They started working with two sectors, pulp and paper and distillery, because of many factors, and one of the major factor was the capacity of the industry. So tanneries were small in size, in investment and so on, and they were more scattered than these two sectors. Distillery, of course, is a very organized sector. Big players were there. Pulp and paper, again large in numbers, slightly, more scattered than distillery, more unorganized than distillery, but far better organized than tannery and other small scale industries. So they targeted two sectors, distillery and pulp and paper. I'll discuss the case study of pulp and paper sector. So it all started in 2008. IIT, so CPCB involved academic institutions, and probably that was one of the first kind of exercise CPCB did with. So of course they used to have academicians in their committees and experts are there. But this work was completely participatory in nature. So Central Pollution Control Board, they acted as a facilitator. The whole work was given to consortia of IITs, right? And for this particular sector, pulp and paper, IIT Roorkee, IIT Delhi and IIT Kanpur. Three IITs formed a team, and then we worked on this. So what we did in the beginning, we analyzed the pulp and paper industry in this basin, and since we were focusing on Ganga till Allahabad, so we identified 4 clusters. One is in Uttarakhand, 2 in Western UP. So let's say, for example, Meerut, Muzaffarnagar, Kashipur in Uttarakhand, and then there is another cluster, Muradabad and Bareilly. Why we are calling them clusters? So for example, within the radius of 15 kilometers, Muzaffarnagar has got around 20 pulp and paper mills. Kashipur again within 10 to 15 kilometer of radius. So again, exhaustive study of industries were taken to understand the problem. Because on paper, so before that also there were discharge norms, and on paper all industries were following discharge norms. And if we do that calculation, that if all industries are following the discharge norms, then drains or tributaries or rivers should be clean. But the fact was that these industries were not doing, they were not doing the, they didn't take any step for treatment of effluent. So they were discharging effluent without any treatment or with a very minimal treatment. So after that, benchmarking study was done. Means what are the best practices available in in India, and what are the best practices available internationally. Again, the whole exercise was participatory in nature. Industries were also involved in the process. And then a charter was formed. So charter was very extensive. So there were 2 features in charter. One was setting benchmark standards. I will talk about this. And a very unique thing was included in this charter was parallel to BET. So in European countries, what you see, they come out with best available technologies, right? So normally what happens in India, that CPCB come up with regulations, means they just give you discharge norms. How they look like? They will say that you cannot discharge BOD, or BOD should be less than 30 mg per liter. Say TSS should be less than 100 mg per liter. pH should be within range 6 to 9, like this. So pH all of you understand, I need not to explain. So they make certain standards. TSS all of you probably understand. Total suspended solid. Suspended solid I need not to explain. All of you understand what it is. BOD, how many of you have heard this term called BOD? Biochemical oxygen demand. This is how organic pollution is defined in wastewater, right? So organics you cannot characterize at a compound level. So you cannot identify, there can be hundreds and thousands of organic compounds in wastewater. So there is a unique property of all these organic pollutants. And what is that property? They get oxidized, right? Naturally they get oxidized because there is a microbial population available. So for them it is a food. If they get oxidized, so during the process of oxidization they will be needing oxygen. So there will be a biochemical reaction where pollutant is getting oxidized, okay, and getting converted into the elemental thing, that is CO2 and so on, CO2 plus H2, okay. But for that biochemical reaction, what do you need? Oxygen. Oxygen is required, right? So from where this oxygen is coming? Water, the stream in which this pollutant is present, okay. That means this process will consume natural oxygen which is present in the water stream. It means what? It means that oxygen in that water stream will get depleted. So there is a dissolved oxygen in water. You know, all of you know that, right? And one of the parameters to understand whether water is good or not, quality of water is good or not, is measure the DO, dissolved oxygen. How much higher is the dissolved oxygen, better is the water quality. Of course, there is a saturation limit. So what happens that with the oxidation of this organic matter, oxygen is depleted. That is why it is called pollutant, because it is depleting the oxygen. Okay. So we call it oxygen demand. So there is a parameter which is designed called biochemical oxygen demand. Means if this effluent is discharged, then 1 liter of this effluent will require 30 milligram of oxygen. This is how you can understand this. Okay, right. So these are the standards. This is how they used to work. Now, whenever they were asked to take certain stringent measures, what they will do? They will say, okay, let us reduce it to 20, let us reduce it to 50, and so on. Right? In this charter, the first thing we decided that this charter is going to be voluntary in nature. Right? That means no regulations. Later on, based on the charter, they modified discharge norms through acts and regulations. But this charter was not part of acts and regulations, right? Okay. So beyond this, what we propose that there should be a concept of best available technology. What was the idea? Idea was before this standards, before new standards, earlier also they were following certain standards, right? And as I mentioned, और देश आ सकते हैं? हाँ? Last year. Okay, so yes. Now the question is, if one industry is saying, yes, we are achieving this norm. The question is whether they have system available in their industry which can achieve this kind of discharge. See what must be happening. There will be some effluent. This is process. They are generating some effluent, and then they have ETP, effluent treatment plant. Okay, and then the final effluent. Okay. Now this system should be capable enough, and let's say BOD here is 280 milligram per liter. That's it. Just some value. Now this system should be sufficient enough, or this technology should be appropriate so that it can reduce this BOD to 30. Isn't it? Right? How many of you have been to any PUC station? How many of you run scooter at home or car at home? Yes? You saw that?
Yeah.
What they do?
They check for position.
And then? So what they measure? They measure the concentration of certain pollutants. He's right. So they, in the exhaust pipe, they insert the probe and they measure SO2 concentration, carbon monoxide concentration. Okay. And if concentration is above then the limit, what they do? Very simple. In case of this vehicular pollution, what they do? They increase the, you understand, probably all of you understand, air to fuel ratio. So in that case it's very simple, just increase the air to fuel ratio, pollutants they get diluted and they give you PUC, and for that they charge. It's basically bribery, illegal thing they are doing. So engine is not actually performing well. Right? So when government comes up with new standards, new air quality standards, what they do? They emphasize that you come up with new design. That is why we have BS4, BS6, BS2, these designs. Right? Means what? The technology of engine is not sufficient to give that kind of air quality. Right? So the same concept we brought here and said that there should be certain suggestions on the technology. So industry has got different unit operations, right? So pulp and paper industry, for example, there will be biomass coming in. Biomass will be getting converted into pulp, then washing, then bleaching, and then paper making. And each section you generate effluent, right? So for each section we came up, so that is what I said, that we analyzed the best available practices in India and international paper companies, and then we suggested them that these should be the technologies employed in your industry. So we change this term back and we call it BMT. It's a very unique term. You won't find this term in any literature related to environmental pollution control. This is bare minimum technology. Right? What does it mean? So if you go to market and purchase washing machine, or if you go purchase air conditioning unit, they say certain ratings, and they say that this will be the power consumption, right? So if you have starting from single star to 5-star air conditioning unit, so there will be certain requirement of electricity. So with this bare minimum technology, what we said that minimum you have to go for 3-star. Below 3-star is not acceptable. Single star, yes, there is a technology available. There is a AC with single star, there is a AC non-star, there is a AC 2-star, but sorry, you cannot use below 3-star. So this was the concept of bare minimum technology. So let's say washing, pulp washing. So there are different designs of washers available, and these different designs have got different water consumption, right? Different level of cleaning, right? So we said that these washers are not allowed. You cannot use these washers because this technology is old, obsolete. If you use this technology, then water consumption will go up, right? So that is the concept of bare minimum technology. benchmark, not only these concentration standards, beyond that, water consumption. So if you are making 1 kg of paper, how much water you are consuming? Before that, there were no such standards, right? How much effluent per kg paper you can discharge. So this was implemented in 3 stages. We call them short-term measures or short-term benchmark, medium-term, and long-term. So there were 2 things. One, the existing things. So we took certain measurements. So what is the existing status? What is the average water consumption? What is the average effluent discharge within that cluster? This is the international. And then we divided this gap in 3 stages. So in short term, we come to this point, then this point, so that they got certain time. So within 1.5 years, they have to implement this. So if we go by regulation or act, then they have to do it immediately. So that is why we took a different approach. We gave them a time moratorium, saying that you implement, you have to move from this to this, but not immediately. For even short-term period, short-term measures, you have 6 months, 3 months, whatever. Basically, it was an 18-month exercise, which ultimately got implemented in 2 years. So, the charter, after the detailed study, the work started in 2008, and we completed it by 2010. Then there were a lot of discussions. Ultimately, it was implemented in 2011, and the industry, the sector, completed this exercise by 2013-14. The whole Ganga basin, it was implemented. So this charter was prepared for 4 clusters, based on 4 clusters, but then it was implemented from Uttarakhand to Bengal, for the whole basin. Implemented, so around 120 plus 130 industries were there, right? I'm not going into the detail. There were, you can call it a watershed. This, आ जाओ बैठा है वो किसकी क्लास है? 755 पहली बार आया फिर कभी और मिले तो okay so this was right so there were so many for example I just tell you anyone from chemical engineering okay. He can understand better than anyone else so what actually happens when you do pulping so pulping is a process I'm showing it because it's very interesting case study and so many such initiatives are being taken place in India. Okay. So what happens that there is the biomass, then chemicals. So chemicals is nothing but alkali, sodium hydroxide. So what you get is pulp. Biomass means chips of tree or maybe bagasse or something like that. And then you get black liquor. It is a liquor, but it is black. That's why it's called black liquor. So what it contains? It contains majorly lignin. So what happens in pulping? So biomass contains cellulose and lignin mostly. There is hemicellulose also. So lignin is a kind of binder, and we want fiber to get free. So lignin is removed in this pulping. Okay, lignin is also organic. So lignin comes to this black liquor. So basically it is soda lignin because now it reacts with sodium. So it comes to that, right? So the COD it has got it is highly polluted effluent. If you consider this as an effluent, so BOD is as high as COD is as high as 1 lakh or maybe more than that. Means if you discharge this black liquor, so within say 100 meters, aquatic life will be almost finished. DO will go to 0. It is not toxic that in that sense. So, but at the confluence point, near to confluence point, dissolved oxygen will become almost 0 because this has got very high oxygen demand. Okay. Now, what is happening? If you look at the paper making process, this is not actually discharge. This goes to another unit of operation called chemical recovery. What is chemical recovery? So this black liquor is concentrated, fired. What do you get? So because lignin is there, so there is a calorific value. And sodium we get in molten form, right? What we get is sodium carbonate. What we use? Sodium hydroxide, and after recovery we get sodium carbonate. But that means you are recovering sodium, right? And then lignin is converted into energy. So that is the recovery boiler, you get the steam. So basically it is recovery of energy as well as chemical. So sodium is not going into the water stream. So this is an integral cycle of paper making. So any standard book, textbook you refer, you will find chemical recovery along with the pulping. But what happened in this basin? Most of the industries are using agro residue, right? Like bagasse, I said, wheat straw in some cases, rice straw. No, none of them are using now. Earlier they used to. Now, most of these industries were small in nature, 50 tons. They got machines when they started their operation. They were very small entrepreneurs, not very big business houses. They got their machines all scrapped from European countries, and they were just playing on the margin. They made a lot of profit, no doubt about that. But they made an argument that since we are using agro residue, we are already doing waste management. However, agro residue is not a waste, but they claim so. So let us not, go for this chemical recovery. And that time CPCB and State Pollution Control Board, I'm talking about 90s or 80s, 90s mostly, they were allowed, and they said that we will not be able to recover chemicals, we will do the treatment for this black liquor. And I tell you, treatment of black liquor is not possible. Right? So basically what they were doing? They were discharging this black liquor to the water stream. Now imagine someone discharging a black liquor of 75,000 milligram per liter and claiming that no, I am not, I am discharging just 30 milligram per liter. This was the status. Right? If in the daytime, so and they used to discharge this in the night time more than the daytime, of course, because society, people living nearby, they can always observe and they can complain. So all that was happening. So one of the things in BMT, we suggested that no industry can have chemical pulping without chemical recovery. A very big intervention, right? And it was rational argument. So when we initially started with only standards, industry people said that this is not possible, these standards are stringent. But when we came up with this idea, then they had no argument. Because it is purely academic argument saying that no pulping is possible without chemical recovery. We could ask them, tell us the process where you can reduce 75,000 milligram to 30 milligrams per liter, and let us see your facility. So ultimately, 2-3 years they could understood, and this exercise was so well planned, well executed that they all accepted. Slowly they all accepted because they had no choice. Although it was voluntary in nature when I mentioned, but CPCB very smartly asked them to give the bank guarantee with affidavit saying that yes, we are going to implement it. Now, with the bank guarantee and affidavit, they were bound to do it. Otherwise, with any inspection, the industry would have been closed. Anyway, now I come to the next part of it. When we were having meeting with them, most of them were claiming that this is not going to work and they all will stop functioning. Industry will close. We are too harsh on them. Right? This was their collective voice. But when individually we used to meet them, they all used to agree that okay, we'll try. Right? 2017 and 18. Three IITs, three of us, IIT Roorkee, Delhi and Kanpur, we decided to go for an independent study. How the implementation of this charter, or what is the impact of the charter, right? And I mentioned independent because we did it randomly. Extensive sampling was done. State Pollution Control Board and CPCB, even Central Pollution Control Board people were not informed. Of course, this study was funded by CPCB only. But when we planned this study, we had this, point in our proposal that CPCB will give us a blanket approval for 1 year. So basically, there is a rule that no one can enter into the premises of any industry with the pretext of taking samples. No, they have right to say no, except Central Pollution Control Board, right? So Central Pollution and State Pollution Control Board, of course. So Central Pollution Control Board then made a notification all industries in this basin or wherever we wanted to do this study that this team is allowed to take sample whenever they want, day, night, any shift, any day, they cannot say no. Right? So, industry normally works in shifts, 8 hours shift. 24 hours production is there. So, we took 36 samples, 12 samples in each shift. Completely random exercise. So, for example, I come to you, to your industry, stayed there for a day or 2 days, took 6 samples, went away. Again, after 10 days, which was not informed to industry when we are coming, even state pollution control board people were not doing. And what we saw, the results were unbelievable. And you know, this report was released, when we released this report, it was released, so minister also attended this function, it was released in Delhi. 95% of the case, of course, there are, you know, there are black sheep, you cannot change them, but that percentage was just 5%. Let us look at the achievements. No industry was having pulping unit but not having black units. Very big achievement, right? And see what Central Pollution Control Board did. So, industries, they gave in writing to Pollution Control Board that we are switching from chemical pulping to waste paper. So, paper can be made from waste paper also. So, currently, India is producing, so major share of India is now coming from waste paper. And this is mostly because of this charter. So, when we started this charter, the waste paper based paper share was around 30%. Now it is around 70%. Right? So, but that's fine. So, what Central Pollution Control Board, so what they used to do? They are saying that yes, we are only using waste paper, we are not doing any chemical pulping. But their facility used to have digesters, right? Where cooking takes place, where pulping takes place. It's a digester is a pressure vessel, right? Because this chemical reaction takes place at say 8 bar or 9 bar. Okay. So again, what they were doing? They were intermittently doing chemical pulping. Say once in 3 days in the night time, and then again discharging. So what CPCB did? They removed physically. They formed a team with district authorities and local authorities. Along with the police, they went to the premises and they removed those digesters. They threw out those digesters out of the premises off, and they actually cut the digester so that they cannot take it back to the premises. Right? This was implemented. All measures, all BMTs were implemented. We made an estimate. So roughly 200 crore investment was done for implementation of this charter. Also, when we were discussing this charter with industries, they were saying that we need money. CPCB said we don't have, we are not, so we have no such scheme, or in fact it is not our mandate, right? We cannot do anything. 200 crores was invested by industry people alone. Every individual industry invested some amount. Okay. Of course, out of these 130, some closed their operation. I am coming to that data. So 200 crore investment, and when we made some analysis based on the data received by industry associations and some of the very progressive industrialists, you know, the payback period we calculated was less than 2 years. What does it mean? Whatever investment they dead, 200 crore. They could recover it within less than 2 years, which is even better than any new investment. If payback period of any investment in industry is less than 4 years, it is very good payback period, right? How they did it? Number one. So this is the argument which I was making in the last class. So when they implement pollution control measures, what they achieve? Resource conservation. So what is paper? Paper is basically the fiber, and fiber is, so if paper is 30 rupees kg, let's say, or 40 rupees kg, that means fiber is 30 rupees kg or 40 rupees kg. So fiber recovery, I'm just giving an example of waste paper based industry. So fiber recovery was 72 to 76%, say, before implementation of charter. Post implementation charter, it went up to 84 to 88%. What does it mean? Before implementation of charter, this almost 10%. If you take 1 kg of paper, almost 100 gram of fiber was going in the drain. So per kg of paper they were losing almost 3 rupees. It was going in the drain, right? So that was the recovery because of BMT. And BMT is because of, so that we can achieve some standards. We can improve the water quality. We can, so environmental regulation, desire for environmental regulation resulting into certain regulations, let's say in this case charter, that required certain investment. So initially all they were saying that this investment is dead investment, non-productive investment. So industry have a tendency, so they want to invest in a productive thing. Productive means which is giving them production. So finally they realized that this also was a productive. Water consumption from 60 meter cube per ton of paper is chemical pulping. So for chemical it was 80. 80 is also a very good estimate. So from 80 they came down to 20. For every liter of water they need to pay certain cess. That is reduced. They are getting water from groundwater, or even most of these industries are getting water from ground. So extraction of water, energy cost, that is saved. So resource conservation in a big way. If you talk about waste paper industry, their water consumption was in between 30 to 40 meter cube per ton of paper, and today all of them are less than 8 actually. I'm talking about today's time, but in 2017-18 also it was less than 12 or 10. This is the status. I mentioned that 90% of them were complying. We did some study in Kashipur cluster. So because they discharged their effluent in the drain, and what we found, in almost every case they were actually doing the dilution. Means, so what we call upstream and downstream. So there is a drain. Industry is located here. It is upstream. And this is downstream. So if we took the sample from this point, the quality was inferior. And once the effluent from industry confluences or get into this drain, downstream is quality. So downstream quality is superior than upstream quality. because of all of them, they were achieving less than 20 milligram per liter, less than 40 milligram per liter TSS. Excellent, right? Now, it is possible that some of them still play mischievous, they can do. But what I am trying to tell you is that the capacity of each industry has reached to that level. Yes, they can achieve this. And if you talk about so maybe as I said that some industry got closed, some new industry came up. This number now, if I compare today, so today the production of the whole basin has gone 3 times up. So let's say before the charter, if they were producing X amount, today they are producing approximately 3x. Their production capacity is 3x. So output is actually increased. So all apprehension. So remember, inflation. Why inflation? Production will come down. Unemployment, because production will come down. But what we have seen here, production has gone up. Number of industries has gone up. Employment has gone up. Even the skill requirement, because in the charter we also included what kind of manpower is needed to run effluent treatment plant. We also mentioned that they should also have, we also ensured that they have water testing lab. So, in fact, within the sector also, manpower went up. Maybe, if you take a particular industry which is closed, then they can say that yes. But overall, I'm not talking about the overall economy. I'm talking about sector specific thing. So even there is no correlation available within the sector that due to the environmental norms or measures, any macroeconomic impact happened. Okay. Other than this, today if you see, what is the employment scenario in wastewater treatment sector? Huge opportunities. Within 10 years, this sector has grown tremendously. So, 10 years before, sewage treatment capacity within Ganga basin was less than 30%. And that also I am talking about the installed capacity. Whether it was functional or not, that is another question. What does it mean? So all the towns situated in this on the river bank of river Ganga, we were able to handle only 30% of the sewage. Rest sewage was going directly to the composing directly to the river Ganges without any treatment. So capacity was 30%, less than that, less than 30%. In fact, actual treatment was even lesser than 30%. And today, you can imagine the growth this sector has seen. At that time, there were 1 or 2 big companies, few small consultants, that's all. Today, huge competition. We have all multinational companies working in this area. And as per my information, 100% sewage capacity projects have been awarded. That means, for Ganga, if I am talking about, if Ganga major stamp, we are generating, let's say, 1 lakh MLD, 1 lakh million liter sewage per day. So, National Mission for Clean Ganga has either implemented or some projects are in the process of implementation and some projects are in the process of tendering is complete. They have saturated, they have made plan for treating all 1 lakh million liter of sewage. Plan means tender is awarded, work has started. Right? Now you can imagine the kind of growth, employment opportunities, improvement in water quality, ultimately improvement in drinking water. So every sector, so ultimately everything is going to the GDP. It is giving boost to the, it has to give to the boost to the. So I think we have good case studies now available within Indian market. So although I shared some of the published, although this study is published in my last presentation, but I thought that let me share this case study also with all of you. Okay. Now we come to the new topic. So what we have discussed so far, two major outcomes of our discussion so far. One is with economic activity, you have positive utility, then you also create pollution, which creates negativity, right? So our task should be to have a trade-off between these two utilities. This is one we have. Second thing, in the last two lectures, we talked about externality. Means there is a problem of commons or common property, and that problem is externality. And what for us the major concern is negative externality, right? And the challenge with negative externality is that it is difficult to internalize this, right? Now we come to a third concept. Since we have to bring everything into our economic system, that is the whole idea now. Hypothetically, we are talking about limit, we are talking about threshold activity, but we all know that that threshold activity is very small. We cannot live within that limit. We have to cross that limit. If we cross that limit, then environmental get damaged, right? The question will be that how much need to be controlled and how much need to be. So one fact is that we cannot remain below the threshold. That means we are going beyond the threshold limit. Once we cross the threshold limit, the question is, so another way of coming back to threshold limit is whatever pollution you are doing, control it not by stopping the production but by treatment, okay? Or other way is that you discharge everything which will degrade the. So similar to this trade-off, any economic activity, if you look at the pollution, there are two things. One, we can create positive utility by controlling pollution, or create negative utility through discharge, because discharge will cause, right? Okay. Now, if you look at this problem mathematically, so let us convert this problem into an economic statement and then we'll convert that into a mathematical function. So this positive utility, that is controlling pollution, cost something, isn't it? You have to do some capital investment, you have to do some operational expenditure, then only you will be able to control. So, any sewage treatment plant, for example, or let's say any new car with new standard. So, BS6 is costlier than BS4. If you have another car with better or more efficient engine, and then again efficient in terms of emission. So, pollution control measures require some investment, capital and expenditure, or the. So, there is a cost. If you discharge the effluent, it creates negative utility. In terms of economics, this again is a cost. The only difference in these two costs is this is a private investment, private cost. If as an industry, let's say, or as an individual, if I need to control pollution which I am generating, who will be paying the cost? I will be paying the cost, right? But in this case, it is a societal cost, right? Purely societal, purely private, purely societal. But this private cost also is a part of the society. So ultimately, both the costs can be considered to be the societal cost. And we make a sum of these two costs. What we can call is total cost of disposal, isn't it? So with any activity X, we created pollution W, which need to be disposed, which can be this W pollution can be disposed by two ways. One, by controlling it, or by just discharging it into environment. And both controlling as well as discharge have its own cost, right? And that is what we are calling the total cost of disposal, which is sum of control cost and I have given a term damage cost, because this discharge, when it goes to environmental medium, it will damage environment. So quality of environment will degrade, and that bears some cost. For example, you remember the example I took in the previous classes? Hatchery and paper mill. Paper mill is upstream, so paper mill is discharging effluent. Who is treating? Hatchery has to treat the water, right? That cost, if you consider that cost, that is nothing but the damage to the river stream, isn't it? And he is paying for that. Although that is example of externality. But what I am telling you is there is a damage to the river, and that damage is there in terms of the cost incurred by the hatchery. So we are calling it a damage cost because it is damaging the environment, right? So I converted this negative and positive utility or pollution to the economic function, that is total cost of discharge equal to control cost plus disposal cost. If you just imagine this function, this is a function which will have some maximum minimum point. Why? Because control cost and damage cost both cannot be increasing or decreasing, right? Why? Because the quantity of W is fixed. Okay? So let's say if we decided to go for zero control, so everything will go to discharge. If we decide not to discharge anything, then everything will go to control. Okay. So if we decide to discharge small amount, control cost will come down, but discharge cost is going up. So it is like this. So if you want to decrease control cost, discharge cost will increase. If you try to decrease discharge cost, control cost will increase. So there is a situation where we can find a optimal value, right? And that is why this whole concept, which we are going to discuss, is known as optimal pollution. The optimal level of pollution. The terms, when you hear this term, it looks like very weird term. Because we are talking about optimal level of pollution. We are accepting pollution. But actually, pollution is a reality of any economic activity. So therefore, we are trying to look at the economic solution for this problem. Okay? So the economic solution is we calculate the total cost of disposal and optimize this total cost of disposal. Okay? Let us understand the nature of control cost and damage cost. If I plot this damage cost, this is amount of waste, and this is control cost. So you can understand, if I am discharging W amount, or discharging not, I mean I am generating W amount, so this is the amount of waste. So if I start with it is waste control. Let's see this is done. If I so amount of waste emitted. So if I decide to emit everything, controlling 0, means whole W is going to get discharged. What is the control cost? 0. And this is the extreme point. And this is the increasing function. This cost of treatment is increasing function, or y-axis. If you remember, I mentioned in the first two classes that we will be always talking about marginal control cost. Means if we decide to control the first unit of pollution, the cost is very, very small. Let's understand this. You have a sewage treatment plant. Okay. What may be the constituents of a sewage treatment plant? Some suspended material, some dissolved pollutants like organics and all. Okay. So what will be the first way of doing some kind of treatment? Any idea? Okay. Let's say the first will be screening. Putting some bar screen or something, just a simple screen, so some floating thing, some bigger debris, it will be filtered out. That is the easiest. What is the cost? Very low. No power is involved, nothing. But some pollution will be controlled. So for the first unit, your efforts are minimal. So the cost will be very low. Next, what do you do? Sedimentation. What is again? What do you do? Just keep the water in some holding tank and suspended particle matters, they get settled. Again, energy is required only in pumping, then removing that sediment. Again, what you see that 30 to 40% load, pollution load is decreased. Costlier than screen. So this cost is increasing. For next unit, the efforts are more than the very first unit. For second unit, more efforts. Third unit, more than second unit. So with every unit removal, your efforts are increasing. What is the next step? Biological treatment. Those who understand sewage treatment plant. Then the next step after sedimentation is biological treatment step. What is that? So now suspended particulate matter is removed. So what remains is the dissolved, whatever pollutant is there, that is in the dissolved form. And mostly it is organic. Okay? So you look for certain microbial mass, you can eat this organic load, but as I mentioned, this bacteria needs oxygen. So you will be providing some oxygen to it. Okay? So efforts are more than sedimentation. Marginal cost further increases. Because every step, what you see, removal becomes more and more difficult. More and more efforts are required. So more and more investment is needed in terms of capex, in terms of opex. Then tertiary, further. So what remains further? Which is not removed from screening, which is not removed from sedimentation, which is not removed even in the simple biological process. So what do you need? Certain extra efforts. So higher level of treatment. Higher level of treatment means what? More capex, more opex. Right? So more energy is required for separating that pollutant from the water. Right? So the nature of this control cost curve is increasing function. Marginal cost is control cost is increasing with increasing degree of removal. Okay, so I think I need to close. It's already 3. Okay. And of course, this curve depends on the technology. So if we change the technology, this curve can shift upward and downward. So this one curve is for the particular set of technology. With more efficient technology, this curve can become less. With lesser efficient technology, that's all. Right? So this curve will shift upward. But for a given technology, what we can say that this cost is going to increase with every unit of removal. This understanding of nature of the curve is very, very important because we are going for the optimal solution. Thank you. So I think assignment 1 first is already uploaded. If not uploaded, then by evening. Okay, and then all of you must start thinking of forming a group for assignment 2. Okay, so we will be floating assignment 2 also by next week. 3-4 days before that. So for assignment 2, you can take time. Right? Since it is a group assignment, it requires some few minutes also. So you take time for that.
तू बाहर आएगा HD आएगा पिलाऊंगा पिलाऊंगा तब ये एक ट्राई आधा आज दुट्टू पंडित बनाए देता हूँ इसलिए वाला थोड़ा कंट्रोल में बोलने वाला